All right, this is still section 2.1 over quadratic polynomials. This is part 2, though. Okay, there's a couple things I just really want to re-emphasize, all right? I mean, the whole idea is I need to be able to give you a quadratic polynomial. So here's one x squared minus 12x minus 27. Now, I really want everybody to be able to understand the key things that we have to be able to find. That is the vertex, the solutions, and the standard form. Vertex is easy. Standard form is fairly simple once you find that vertex. The key thing that a lot of kids struggle with is being able to find the zero, especially when they don't work out to be so nice and perfect. So I really, really want to make sure that everybody understands how to do that. It does take a little bit of time, but let's go over it. So let's do the vertex real quick, and this should be very easy. Remember, the vertex is a point. The x value of that point is the opposite of b, so 12, divided by twice a, which is 2, so that's 6. And then to find the actual y coordinate, I have to convince my calculator that 6 is x. So I'm going to say 6 stores x. And then I'll just type in x squared minus 12x minus 27. So the calculator is officially convinced, and I get negative 63. So that's I don't know if I'd expect you to be able to graph that because it's so far way down there, but that's a very, very low vertex. It's all the way down negative 63. But again, it's a number. Don't let that think that you can't do it. And once you're done with that, standard form is easy, ready to go. All you have to do for standard form is you need to know a. That goes out in front, so that's 1. X minus the x coordinate of the vertex, which would be 6. Squared, don't forget the square on the outside, and then minus the y coordinate, which is 63. So there's standard form really, really quick. So I love how fast it is to get to standard form. All you need is the vertex. All right, now for the tough part, now to find the zeros. Okay, again, this cannot be factored. It actually seems, to be honest, like it could be factored because maybe you start off thinking, okay, 27 is 9 and 3, and a 9 and a 3 can make it 12 if I make them both negative, because negative 3 and negative 9x make negative 12x. But the problem here is that negative 3 times negative 9 is positive 27, and it says I need a negative 27. So this actually cannot be factored, even though it kind of seemed like it could. So I got to go ahead and use the quadratic formula. So here I go. The opposite of b is 12, plus or minus b squared, and I cannot emphasize enough to you guys, please do not be silly enough to type in negative 12 squared. The calculator is going to lie to you. It's not negative 144. When you need parentheses around, it's my point. But you can just know that it needs to be positive. So it's 144. It's going to be 12 squared there. Minus 4 times a is 1 times c is negative 27. All divided by twice a, which is 2. And the next key thing we need to be able to find is what number is inside that square root. So again, I'm going to do 144 minus 4 times 1 times negative 27. Double check you type that in right. You don't want to miss a negative sign and be off. And I get 252. So 252. All divided by 2. So now my job here is to figure out the square root of 252. If you try to just maybe we got lucky here. Maybe it is a perfect square. I don't think it is. So we have to start trying to figure out what numbers go into 252 that are perfect. For example, does start with some big numbers like 64. That's a perfect number. No, it doesn't work. Let's try 49. That's a perfect number. Maybe that'll work. No. How about 81? 81's a perfect number. It's a big perfect number. Always start with kind of bigger ones before you go to the small ones. No, that didn't work. How about, I don't know, maybe 144, right? That's the perfect number for 12. No. Let's try 16. Maybe 16 will work. No, that didn't work either. Let's see here. 9. I don't know, maybe 9. That's not too bad. Let's try 9. Oh, we get 9 works. But you got to think, wait a minute though, 28 is not perfect either, but 4 times 7 makes 28. So there might be another number here that works. So let's keep trying here. Let's try another bigger. Like I said, always try bigger numbers. Let's try 36. Oh, hey, 36 worked. That's real nice. That means that 252 is 36 times 7. And what that means is that this 36 could come out as a perfect 6. Unfortunately, the 7 is stuck in there, and then all divided by 2. So I finally get 12 divided by 2 is 6. Remember, everything gets divided by 2. 6 divided by 2 is 3. radical 7. Do not divide the radical 7 by 2 because he's stuck in jail. So there are my two zeros, 6 plus 3 radical 7 and 6 minus 3 radical 7. So just be careful. And this is a pretty big one. I don't know how much I'd be mean and give you one like that on a test or something like that. But, 252 we did have to work out, being 36 times 7. The key thing is the 36 comes out of 6, and then they could both be divided by 2. 12 divided by 2 is the 6, 6 divided by 2 is the 3. And there's a multiplication sign right here. That's 3 times radical 7. All right, let's move on to the next main thing that we need to be able to do. And I want to be able to give you the vertex and one point on the parabola. One random point. And I want you to just give me the equation. And this is actually so easy. It's a lot easier than you probably think. So let's do the first example here. So I'm going to give you the vertex. I'm going to freely tell you that the vertex is 2, 5. Okay? And then one random point somewhere on this parabola. Again, remember this parabola, looks like this, and here's the vertex. I'll tell you the vertex. I'm giving you just another random point. One of the points that's somewhere on this parabola. And I'm going to tell you that random point is a really crazy one, -3, 80. Okay, so I want to find the equation. Now, the first thing is, let's go to standard form, because standard form is so easy if you know the vertex. Okay, standard form says A. Well, unfortunately, I have no idea what A is, so A is going to go out in front. I'll just have to write A for now. X minus the 2, that's the x coordinate from the vertex, plus 5. So I actually am like 99% there. I have everything done. I just don't know what A is. So the vertex is what helped me tell me that I need a 2 here and a 5 here. Now I'm going to use the point to actually determine what my A value is. That point tells me that when x is -3, so I'm going to turn that x into a -3. Everything else is going to stay the same. This tells me when x is -3, the y, which is f of x, ends up being 80. So I know that when the function is 80, x is -3. Or when x is -3, the function is 80. So now I have to just solve this. This is actually really, really easy. First off, -3 minus 2 is -5, right? And then square it becomes a positive 25. Plus 5, right? Okay, so I have to get rid of the addition first, because this is a times the 25. So let me subtract that away, get 75 equals, you can do 25 times a if you'd rather write the 25 in front. And then all you got to do now is divide by 25, and you get 3 equals a. And that's it, you're done. So your final answer, the function is 3 times x minus 2 squared plus 5. So all the work came from trying to find a, and it was just plugging in the x value from your point for x and the y value from your point for f of x, which is y, and then solving. So you just had to do the subtraction right here, get -5 squared makes 25, subtract the 5, and then divide by the 25. So it's really, really easy. Let's do a second one, because I want to convince you that how simple this can be. So here's a second problem. I'm going to give you the vertex. The vertex is -4, 3. And the one point, the one random point sitting on this parabola somewhere is -1, -15. Okay, so we got to think. Standard form of a parabola is a, which I have no idea what it is, x minus the x value. But x minus a -4 makes x plus 4 squared plus 3. Again, the 3 was from the y coordinate. So again, the form that calls for x minus the x coordinate, but since the x coordinate is already negative, that's where it creates a positive. All right, so now I have to use this last point right here, this random point, to help me figure out what a is. So I know that when x is -1, I know that the function, that's -1 plus 4 in there. I know that, wow, it's getting uglier and uglier by the moment. Okay, let me erase that a little bit here, because that just looks terrible. Okay, just erase the whole thing. I'm so sorry. All right, so I get -1 is x plus 4. Okay, looks a little bit better. Okay, and this, when I plug in -1 for x, I get a y or an f of x value of -15. So that's x, that's y. I plug that in for x. There's f of x, which is the same thing as y. Now I just got to solve. So I get -15 equals, let's see, let's do the math. -1 plus 4 is 3. 3 squared is 9, so I get 9a. Or you could put the a in front. It's 9 times a is the key thing. Plus 3. And I need to get rid of the plus 3 first, so subtract 3 over. And I get -18 equals 9a divide by 9, divide by 9, I get negative 2 equals a. And then that's how easy it is. You're basically done already. I mean, you are done. A is negative 2, x plus 4 squared, that came from the vertex, plus the 3. So there's my final answer in standard form. Okay, very, very nice and simple. So that's going to be the basis of what we do the next day in class. And the last thing we're going to do is talk about word problems. You got to understand that, word problems are meant to be easy. All we're doing is giving one of these quadratic functions into a word problem. And a simple thing you could think of is throwing a baseball. When you throw a baseball, it creates this path that looks like a parabola. Now, we only care about the part that is actual realistic, right? Negative values, that doesn't make sense. When you throw a baseball, you can have negative values. So we care about the baseball leaving my hand. It's going up in the air, it's going up in the air, it's going up in the air. Now it's coming down, and it hits the ground. So the part down here that's negative doesn't really matter to me because you're throwing a baseball. The baseball's not going to go through the ground or anything like that. So we care about the positive part of the baseball, and the path of that baseball is followed by a curve or a parabola. And again, the most important part is right here, the highest point, and that is the vertex. And the formula to find vertex doesn't change just because we're talking about a problem that has context to it, meaning a word problem. All you got to care about is, hey, look at that problem, think about how to find the vertex. So we'll talk about that in class tomorrow as well. All right, guys, have a good night. Talk to you later.